This is HRW910P015. Okay, it says a wheel has a constant angular velocity of 3.5 radians per second squared. During a certain 5-second interval, it turns through an angle of 120 radians. Assuming that the wheel started from rest, how long has it been in motion at the start of this 5-second interval? Okay, so this one's pretty confusing if you don't try to plot it out. Now, unfortunately, this is on a wheel. I should plot it on a wheel, but I'm actually going to plot it on linearly because this is the same kind of problem if I had said, like, a car has a constant acceleration of blah, blah, blah. During a certain 5-second interval, it travels a distance of 120 meters. Assuming the wheel started from rest, or assuming the car started from rest, how long has it been in motion at the start of the 5-second interval? It's the same problem. So I don't really need to do, I don't know, it's confusing enough. Okay, so let's say this is the start line. This is where we're starting everything. So this is like theta equals 0. It's starting from rest. Time is 0. Like everything is 0 at the beginning. Okay, and then this wheel turns. And it travels this distance here, and boom, we start our clock. Okay, so I don't know how long this is. I'm going to call that time is t here. Okay, at this place, has some angular velocity. I'm just going to call it omega 1. We're actually not going to use that, so it doesn't matter. And it is turned through some amount of angle. I don't know what it is, but I'm going to call it theta 1. Okay, notice these are all 1s. Okay. Heck, I'll just call this T1 as well. And that's what I'm looking for. I'm looking for T1. This is what I want. Let me here. Yeah. Because it says how long it has been in motion at the start of the 5-second interval. So this is when I'm starting, I'm pushing the button on my stopwatch. So this is the time I want because it's going to measure this. Okay. Then this thing continues going, la la la, still spinning, and boom, that's when I'm stopping. At that point, from the very beginning, the wheel has turned through an angle theta 2. At this point, it has an angular velocity omega 2. And at this point, the time, well, I know that they said when I started the clock, then I'm going to have 5 more seconds. So here the time is T1 plus 5. It's T1 plus 5-second interval. I hope that makes sense. Okay. Okay. Now, I also know that during the 5-second interval, it turns through an angle of 120 radians. Okay, so this right here is 120 radians. What we're really saying is theta 2 minus theta 1 will leave this left over. Okay, theta 2 minus theta 1 is going to give me 120 radians. Alrighty. Now, if I can just find an equation for theta 1 and theta 2 and put them in this equation, that might give me something. Maybe it won't completely fix the problem, but it seems like a good idea because it's information that I know. So I know that for any set of any kinematics equations, that theta equals theta naught plus omega naught times t plus 1/2 alpha t squared. Okay, I know that's for sure. I'm going to full screen this now. Okay, so for theta, see, I want theta 1 and theta 2. For theta 2, I just put in the stuff that I know. So I've got, well, theta naught, this should be naught, I guess, that was 0, so I'm actually just going to leave it out. Omega naught was 0, so I'm going to leave that out too. All that's left is this. This is all that's left. So all I got to do is 1/2 alpha. T is T1 plus 5 as a unit. So T1 plus 5, and then don't forget to square it. Okay. All right, that's all happy and well and good. Theta 1, well, still the same initial conditions, so the first two terms do go away. All I have is 1/2 alpha. This time t is t1. Don't forget to square it. All right, and then I know that these subtracted will give me 120, so I'm going to put this minus that. Okay, so 1/2 alpha t1 plus 5 squared minus theta 1. Theta 1 is 1/2 alpha t1 squared equals 120. Okay, well, this is good. If you look at this equation, all I have are constants. Like 1/2 alpha is a constant, I have it. And the only variable is t1. So I should be able to solve for t1. One equation, one unknown. And t1 is also the thing that I want. So if I can just solve for t1, I'll be good. So let's do some algebra. Well, first I'm going to have to expand this. So 1/2 alpha t1 plus 5 squared. Expand out that square, and I get the first thing in there gets squared plus 2 times the two terms in there. So I've got 2 times 5 times t1, so that's 10 t1. And then you plus the last term squared, so 25. And then I still have this 1/2 alpha t1 squared hanging off the end and equals 120. Okie dokie. Now I've got this 1/2 alpha. I need to distribute it. So 1/2 alpha t1 squared plus 1/2 times 10 is 5. Then I've got my alpha t1 plus, let's see, 25 divided by 2 is, oh gosh, it's Saturday morning, brain fart, 12.5 alpha. And I still got my minus 1/2 from here, alpha t1 squared equals 120. Okay, now notice I've got a 1/2 alpha t1 squared, and I've got a minus 1/2 alpha t1 squared, so those are going to go away. Alrighty, and then all I have is 5 alpha t1 plus 12.5 alpha equals 120. This is a constant, so I'm going to move it over to the other side with the other constant. 5 alpha t1 now equals 120 minus 12.5 alpha. And all I have to do is divide by 5 alpha, and then I'm good. Alright, plug in the numbers for alpha. Let's see, where's my alpha? My alpha was 3.5. Yours will not be 3.5, but mine is 3.5. Full screen again. Okay, so what I have is, oops, hang on. Let's see, T1 is 120 minus 12.5 times 3.5 all over 5 times 3.5. And I get 4.36. Oops. 36 seconds. Let's go check on that. Yep, 4.36 seconds is in fact the answer.